Sean with Ohmmu Energy. Today we're going to show you how to wire up a 48 volt power system as a generator replacement or generator alternative really in a Coachmen, what is this, Catalina Summit Series RV trailer. These are pretty cool trailers. They've got a lot of neat features. It's a newer model, but it's a very, it's kind of a typical RV trailer that you can find all over the place. Millions of these on the road. So any of your camping trailers, this is applicable. What we're going to add to this one is going to be really cool. We're putting in 800 watts of solar, and we use these flexible panels, which we'll talk about later. We're putting in 8 kilowatt hours of battery with Ohmmu Group 31 lithium batteries, some monitoring equipment for that, and then there's a solar charge inverter. This is also going into this trailer. This one unit can pull from the solar panels to recharge the batteries, and it can also pull from the batteries to power the AC side of things. And it can pull directly from the panels to power the AC side of things. It's very much like a home off-grid solar inverter, because that's what it is. And so it's a 3 kilowatt, 120 volts AC inverter, and that will allow this trailer to run all of its appliances whenever it wants off of batteries without making any real compromise or decision about like what time of day it is, and if there's somebody nearby and you don't want to have a generator throwing off exhaust or something like that. So it's a very cool system, and we'll show you all the components and how we put it together. All right, first we'll talk about the solar panels. We use, on this system, we use these flexible type of solar panels. And the reason for that is that it has a lot of roof space. And so what we like to do with these panels is simply install them directly to the surface of the roof without any of the fancy, elaborate solar panel mounting systems in place. It saves money, it makes it much easier install, it makes it much cleaner install, and there's no roof penetrations whatsoever, so you're not dealing with any leaks. The downside, of course, is there's always one, is these panels are not as efficient as the other polycrystalline panels, which are glass at the top. Also, because we're mounting them directly on the surface, we lose a little bit of efficiency to the fact that there's no airflow under the panel cooling it down. So it's a little bit of a trade-off, but that's why I say when you have a lot of square footage on the roof, this is the better way to go, because you can oversize the system. So let's say you really felt like you needed 500 watts of solar. Well, go with these and push up like 800 watts of solar instead of 500. You'll end up getting a similar performance profile in most conditions, but in really ideal conditions, actually, when the weather's a little cooler, you're going to do even better with these, because some of the drawbacks of the heat buildup and stuff will be offset by the temperature outside. So it's a very good way to go that makes for a very clean install. We use an RV tape, which is this thick white, it's like a black, the backside has a black butyl rubber adhesive. It's very thick, and it's water. You actually use it. You can use it to waterproof things. We use that to hide all of the wires and to do a bead around, or just a line around the panels to help seal them down so nothing gets underneath. We also do silicone under the panels and press them down into the silicone, so they're very well adhered. And with the RV tape, we're able to take off the chances of any loose wire flapping in the wind while you're driving down the road, because all of those are going to be hidden underneath this RV tape. So when you look down the RV from above, if you have such a vantage point, you'll just see the panels, and then you'll see like these tracks of just like white RV tape where all of the wiring is kind of just hidden underneath that. So that's a very cool way to go, and I recommend it. It's the way that I typically do systems around here. All right, let's talk a little bit about the batteries. These are, of course, Ohmmu Group 31 batteries, 156 amp hours a pop. They're our current generation battery. There is a future gen coming out soon that'll be even more capacity. So stay tuned. I won't do any big reveal now, but they're getting even better. But right now, these are 156 amp hours, which is awesome. Blows away all the rest of the competition already. The equivalent in Battleborn performs at maybe 60% of what these batteries do. So it's a huge trade-off to use some of those other brands like Battleborn, where you just have to put way more battery in there to get to the same capacity and capability as you get out of these Ohmmu batteries, which are really a much more capable battery, which is cool. So in this system, we're putting 4 of them, so we're gonna have 8 kilowatt-hour battery bank. The one thing to be mindful of when we're doing a battery installation, of course, is voltage, and that's what is the voltage going to be in the system. 12 volts is just one battery or any multiple of batteries. You can do 13 batteries and wire them all in parallel. Parallel means all the negatives are connected to each other, all the positives are connected to each other, thereby creating one large 12-volt battery. And you just add all of the amp hours together to get the total capacity of that 12-volt battery system. In this case, we're doing a 48-volt system. So that actually means that we're putting 4 batteries in series wiring. So the positive of one of the batteries is going to be the ultimate positive of the system. That's going to connect into the system. And then the negative on that battery will go to the positive of the next. The negative on the next battery will go to the positive of the next. Negative, positive, and then finally at the 4th battery you have the ultimate negative. So then you have a 1 ultimate negative, 1 ultimate positive, and those are the 2 that'll go to the actual system. Because it's in series wiring between that negative and positive, the voltage is going to be added together. So rather than a 12-volt system, this is to create a 48-volt system. And the reason that is beneficial in situations where you have the opportunity to do so is that higher voltage equals higher efficiency. And so with things like running an inverter where you're going to have a significant amount of energy available to you and you want to run it for hours and hours and maybe days at a time, the efficiency makes a difference. The difference between like an 85% conversion efficiency up to like a 92% conversion efficiency is significant. The other bit to that efficiency is you get to use a little thinner wiring, which of course is just cost. I mean, you could use thicker wiring, but it's also less practical to use thicker wiring. So when you're dealing with a lot of energy, you go higher voltage because you can use less wiring because of the increase in efficiency, because there's less amps. And then the other benefit to that is, of course, with the thinner possible wiring and the more efficient energy system, you produce far less heat in the system. So you don't build up as much heat in the electronics that are running at 48 volt versus electronics running at 12 volts, all of things equal, meaning you're powering the same size of a load. So all of that means that a 48 volt power system is more efficient than a 12 volt power system. And in the case of an RV trailer where we're getting every bit of usage potential out of the system is advantageous, we're pushing a 48 volt system into this trailer, and I recommend it if it's possible. So if you only have space for 2 batteries, maybe go with a 24 volt system. If you don't really have the means to do a 48 volt system for your inverter charger and you already have stuff set up in the trailer for 12 volts, go ahead and go with 12 volts. It's fine. It's just not going to be quite as efficient, so you lose a little bit of runtime because of that. But when you're going fresh start and you're designing your system from the ground up, the higher the voltage is better. So that is why in this system we're going 48 volts. The other caveat or gotcha is that you'll want to do something to help balance the batteries, because each battery has a BMS internally that will balance the cells. So there's going to be 4 cells in series in one of these big batteries, and it's going to balance those cells amongst each other with the BMS that's inside of this battery. But this battery compared to this battery compared to that battery compared to that battery, they don't have a means for communicating with each other or cross-balancing between the full 4-pack or the full each of these batteries. So throw in a battery equalizer that's a 48 volt battery equalizer system, and what this does is each of these ends will go to one of the batteries. So one battery is here, and the next 12 volt battery goes here, and then so forth. And then when you're charging, this will kick on and balance the batteries for you at the top end of the charge cycles. So that's very good. And if you're going to use if you're going to do series wired batteries, highly recommended. You need to do something to make sure you're balancing cells. That's why in like a 400 volt battery in an electric vehicle, there's a ton of electronics that go along with that, because it's all about battery management. And so you've got a very elaborate battery management system, because at 400 volts, you're dealing with many cells in series, 100 cells in series, really. So that's a lot of batteries that have to be kept at the right or similar voltage throughout their life. And so that's what a battery management system does. So make sure you throw an equalizer into your system design for anything that's over just 12 volt strings. That's the huge benefit for just going with 12 volts though, is you don't have to do something like that. So trade-offs. Okay, the last chunk to the system is the solar inverter and charger unit. And this is just a kind of a cheaper unit that gets the job done. They have decent power output ratings, and they produce a clean, pure sine wave. So their PowerMR or Palmer, I don't know how they intend to have you pronounce it, but these are available on Amazon, and they have a range of different options. This is a 48 volt, 120 VAC, 3 kW inverter charger. So solar panels will get wired. They'll connect directly to this, and the battery bank will get wired and connect directly to this. Then on the other end, on the AC side, we're going to be connecting it we're going to intercept basically the current shore power cable that plugs in, and then it brings power in to feed all of the loads inside the trailer. That will instead first stop here, and then the output of this will continue along that line to power all of the 120 VAC loads in the trailer. So what that would allow you to do is, if you do plug in, then this gets shore power, and it uses that shore power to go ahead and charge the battery bank, and allows some of that energy to pass through to power the loads. But if you don't have shore power, you just simply flip the switch to turn this on, and to the trailer and everything that's been installed in the trailer already, to all of the existing systems, it's as if you just plug the trailer in. No difference. And so it's just going to get fed power the way that it's used to getting power every time you plug the trailer in. So that also means you can do load transferring and stuff like that. So you can run things while it's plugged in, and as you unplug it, nothing turns off. Everything would just stay on, because you unplug it, then the load will transfer to the batteries by this. So it does that switching for you. So it's pretty cool. It's got a lot of neat features, and there's a lot of settings on them. So we can go through that maybe in another video, or reach out to us and ask if you need help with setting those up, because there are a lot of different like little nuanced settings for things. Nothing overly complicated, but there's just a lot of available settings. Okay, so let's do a little walkthrough of the after install in the battery bay. So we've got the 4-pack of batteries here. They're all wired in series. We've got the DC balancing, well, really called battery equalizer. The battery equalizer, they're hanging. Every one of these batteries is connected to the battery equalizer. Then they're wired in series, back and forth. And then the positive and the ultimate negative come out and flow through to here, where the negative goes straight to your battery minus on the smart shunt. Make sure that there is no load that's connected to this side, to the batteries whatsoever. No charging, no discharging, nothing. The only thing that you can put there is the equalizer. Every load needs to come off of this side to system minus. So in this case, we only have one. So we're going from system minus straight to the inverter. And that's okay. That's the only thing that's connected to it. And then on the positive side, we're bringing it into this disconnect switch so that you can turn the whole system on and off for servicing inside of here. So the positive comes in here, and then it just comes right back out, and you can turn this switch off. So this would be in the off position when the little notch is pointed to the red, and then on when the little notch and the arrow are pointed to the green section. In this case, the master power distribution unit, which has got like the DC converter in it and all of the circuits, the AC circuits, it's actually just located right on the other side of this wall. So we were able to intercept the wires right here and just bring them in. So the way that I like to do these is you find the source wire that powers the whole trailer, the one that's coming from the plug, and you intercept that wire. You bring that wire in as the supply to your inverter charger, and then on the output side you take that back out to what those wires would have gone to, which is that converter. That allows you to use this as your main source of power, but also when you plug in, this will units like these will automatically transfer the load to the grid, and at the same time they'll provide some battery charging to your battery bank straight off of the grid. So that works really well, and then that allows you to basically use this as a generator, and you can power the whole trailer. So if we power this on, so there's a little turn on master on off switch down there. So we're going to turn it on, and then that's going to boot up, and there's a bunch of settings that you'll want to set on these based on your batteries and all that. So once that's booted up, then actually it'll start powering this whole trailer on the AC side, and then you can run the air conditioning, microwave, anything you want. And right now we're parked inside of a garage, so we're not getting any solar power, so all the power will be coming out of these batteries, which is fine. There's plenty of juice in there. Then, of course, the last thing that I didn't talk about yet was the solar wiring, which is right here. And they're both red, but it's a positive and negative off of the solar. We did 2 groups in parallel. So those panels are 18 volt panels, 21-ish volts open circuit voltage. So we went with 2 groups of 4, so 2 parallel group series of 4. So it's a total of 8 panels. So we've got a, let's see, that's going to be 72 volt, 2 groups of 72 volts, which are then in parallel down to here. So this is going to see 72 volts coming from all the panels up top. For a total, it should be, hopefully we'll get performance somewhere close to 800 watts. That'd be great. This can handle like 4,000 watts coming into it, so that's no issue. Then the wires, the DC wires for solar, make sure you're using solar grade wiring. There's going to be some exposed wire, but solar grade wire is just, it's got a lot of extra insulation, and UV exposure is it's built for it. All right, we're inside now. We've got the lights on because we've got power, so turn the interior lights on. Here is the main distribution panel I was talking about. So this is where, you won't see it, but we took this panel out, and then we got the wires, the main feed that comes into this, and that's the wire that we cut that wire, and or you can just disconnect it depending on how much extra wiring you have. In this case, we were able to cut the wire and then use the slack to actually not have to disconnect the wiring coming into this panel, which was great. But typically you're not going to be able to do that. So typically you will you'll have to bring a new wire in and do it with new wiring. But basically you're going to take, so the main wire that feeds, or the set of wires, the 3 ground, hot, and neutral wires that feed the trailer from the shore power, you're going to intercept that wire before it gets to this panel. Take that to your solar inverter, as long as your solar inverter has an auto transfer switch inside. Use that on the input, and then on your output you're going to feed this panel the same place where the grid would have otherwise fed it. Then you've got basically grid backup by using your solar inverter. And this trailer, actually, if you were plugged in right now, it'd be running electricity off of the grid and charging the batteries, and you'd be all fine with everything running. And then as soon as you disconnect it, the auto transfer switch would just transfer the loads over to the battery, and everything would just keep running. Now this is a trailer, not an RV, so You're probably not going to do that because if you're going to disconnect from the grid, you're probably about to go, and you may not want to leave everything running anyways while you're driving, since nobody's back here. But there's some things you might want to leave on, like the refrigerator, something like that. That's fine. Yeah, so this is all powered now through the batteries. It's pulling about 2 amps with just the lights on, and probably some very small loads otherwise. But you can see the awesome thing here, which is we can run the air conditioning directly off the battery bank. Now that puts some load, of course. With this particular air conditioner, it's actually not horrible. It was pulling about 25 amps after the initial startup. Startup load is 30-35 amps out of the batteries, drops down to about 25 amps, but it keeps it nice and cool. And with this particular battery bank, I mean, they have 156 amp hours, so 25 amps, it's still going to run for half a day, which is awesome. So that is everything on this trailer. Here we go. We've got 2 groups of 4. So there's a rear group with these 4 panels, which are all in series. And then the wires run, the main positive and negative from this group come up here, up to the front, and then they parallel in with this group of 4, which is also run in series. So you've got 2 4s, and then they're bound together for one set of wires that runs down. It's easier to do it with one set of wires running down than to bring both sides and join it down there, because the wires can handle the current for something like this. I mean, they can handle like 15-20 amps, and this is going to be never more than half of that. So it's just easier to run less wires. And so that's how this is wired up here. We didn't have quite enough of it, so we're actually going to finish this later with more tape, because these areas where you see exposed wires I don't like. We're going to end up covering those. But this is this RV tape that we put in between all of the panels and along the edges of all the panels. Underneath the panels also there's silicone going in a back and forth pattern, and then along the edges, and then big X's. So there's a decent amount of silicone, and then they're pressed down into their spots. And then that RV tape is along the edges to make sure no air or water kind of seeps in from the edges. And then we also hide the wiring with more of that RV tape, just to keep the wires from, one, flapping onto the panels and ruining some efficiency. That's not a huge amount, but something. But also just to keep the wires from flapping around in the wind as you're driving, so that they stay intact and healthy for a long life.